Hello, everyone, and welcome to this webinar by Security Boulevard. And the webinar today is going to be presented by SNCC. A couple of things before we start, just some housekeeping rules. The event today is going to be recorded, and we will send you a link to the recording of this so you can watch either the replay, or if you can't make it live, you can watch that replay for the first time in an email very shortly after the recording has been completed. You can also ask questions to our speaker throughout this session. The speaker will be taking questions and answering them at the very end. You can do that through the control panel in GoToWebinar. So on that control panel that you're watching this from, if you open the questions twisty, you can ask your questions in there and I will ask them directly to Guy at the end. One last thing before I introduce our speaker, there is one draw for three $50 Amazon gift cards, which will be given at the end of the webinar, and that will be drawn at the end of the webinar. This is kindly donated by MediaOps, the company behind Security Boulevard. Without further ado, the session today is Maturing DevSecOps from Easy to High Impact, and our speaker today is the co-founder and CEO of SNCC, Guy Pojani. Guy, how are you doing?
I'm doing well. Thanks, Simon. How are you?
Very well, thank you, and welcome to this session. And now a couple of things that I'll say just before we jump in. SNCC, the company which Guy co-founded and is the CEO for today, SNCC is a very developer-focused tool that both finds and fixes known security vulnerabilities in your third-party libraries and open source packages which are used by your applications. And Guy, how important is this in the open source packages in terms of how applications can use open source packages today as part of their development?
Yeah, it's a pretty fundamental risk. I mean, it boils down to maybe a similar concept to patching your servers. It's just patching your apps, its components that are vulnerable there. And that kind of really goes back into patching your servers when you talk about securing containers and the likes. So yeah, you should do it before the bad guys take advantage if you're not doing it.
Awesome. So, couple of things. We've got some polls lined up as well. So when the polls do jump out, please do answer them as quickly as you can, and we'll show you the results of that as we go through. Guy, just so that people know a little bit more about you, a little bit deeper beneath the surface here, what would you say is your favorite animal and why?
I guess kind of the Doberman here shows a little bit shows the intent. I would say a dog. I don't know that I'll focus specifically on that, but
Nice answer.
whole, very much a fan.
Nice answer. Awesome. So, Guy, without further ado, over to you.
Cool. Thanks, Simon. And thanks, everybody, for tuning in. Hopefully you find this interesting. So I'm indeed here to talk to you about maturing DevSecOps and kind of go from the base implementations, maybe the evolution, the first step in the evolution, to the highest impact that you can have. A couple of words about me, just for context, from what I might know and might not know. I'm the CEO and co-founder at SNCC, as we just talked about. And prior to that, I spent basically about a decade in the world of application security before it was cool, talking about what SQL injection is and cross-site scripting through the first web app firewall, web app security scanner in AppShield and AppScan. So built an application security type of knowledge. And then I went into more the ops world, building a performance startup and being CTO at Akamai when it acquired it, dealing a lot with DevOps and with the transition and the revolution that world has gone through. So I kind of have these two different perspectives that I hope I kind of bring to fore and help merge, and SNCC very much travels in these worlds as well. So let's dig into it. So I think if you're on this webinar, you probably love DevOps. You might sort of love and hate it, but you probably have the love component as well. If you don't love DevOps, you're kind of welcome to leave the webinar. Just joking. But sort of why? Why do we do DevOps? You Google this or you ask 3 people, you're going to get 7 opinions. I'll use this definition of it, which is fundamentally we do DevOps because we want speed. We want to be able to deliver value faster, and we want to be able to respond or sort of adapt to market needs faster. And we want to do all of that at scale, not just because of a small team that does it, but something that is broad. That helps us eventually drive better business outcomes because we're more productive and because we move faster. So we want to do DevOps, but what does that even mean, right? What is doing DevOps? Well, there are a lot of different interpretations, again, to how this would work, but I'd use this structure that I will use kind of throughout the talk, which is There's DevOps technologies like containers and cloud. There's DevOps methodologies like microservices or CI/CD, continuous deployment. And there's the notion of DevOps shared ownership, that you don't just throw code over the wall, but you share the ownership of it between the developers and the operators. Now, before we continue, we're going to run a quick little poll here just to understand where are the people tuning into this audience in on this journey. So we're going to run, you should be seeing some panel pop up and ask you, where are you on this journey?
Yeah, thank you, Guy. And one of the key things here is this is going to be based on your critical applications. So some of the main applications that you deal with, rather than just
absolutely.
across every application. So, Guy, which ones here do you feel are the most important, or are they as important as each other?
Yeah, and they're very much an evolution for it. So when you talk about technologies, they're the components, the bare bone capabilities that we use to just sort of move in this world. You know, the open source libraries you use, indeed containers. Maybe you're in serverless already. And using those in the most efficient fashion is really what boils down to the methodologies to talk about. You know, you're continuously deploying, and that is both taking most advantage of containers and vice versa. It's sort of you need containers to be able to achieve that. And then DevOps shared ownership is maybe the philosophical driver, right? That is really promoting you know, the adoption and, you know, these methodologies and the eventual technologies that enable them.
Okay, so we're able to share the results now. Interesting results. Just approximately 2/3, I would say, would use DevOps technologies, methodologies, and shared ownership. I would probably guess that it's the similar people using each of these, and about approximately 1 in 10 don't do any at all. So does this shock you? Is this familiar results for you?
No, I think it seems about right, and what we're seeing, I don't know if you're sort of seeing the numbers or not, that it's going from about 70% adopting technologies to more in the 60s, you know, low 60s that adopt the methodologies, and in the 50s that adopt the shared ownership. And it's, you know, I think it reflects a little bit the evolution, but the notion of being DevOps or doing DevOps is fairly robust. So, you know, this is as my expected foundation, and technologies comes, you know, as easiest to adopt, then methodologies, then shared ownership. So let's sort of use this and run forward and talk about, you know, if this is what doing DevOps means, what does doing DevSecOps mean, right? You know, what is that? So we're going to use the same structure to talk about DevOps technologies, methodologies, and shared ownership for security. So we'll talk about securing DevOps technologies, security in DevOps methodologies in your CI/CD and the likes, and then at the end, or kind of at this final step of the evolution, how do you include security in this DevOps shared ownership? And I'm going to use a lot of examples as we go through those. So let's dig in. Securing DevOps technologies. So fundamentally, when you think about DevOps, there are a lot of new shiny objects over here, right? There's cloud, container, serverless. I kind of mentioned a lot of these already. And these unlock, like pretty much anything in this world, and specifically every technology, they unlock opportunities and they unlock risks or sort of problems. Specifically for security, they create two types of problems, or two families. The first problem is really quite mechanical almost, which is that security solutions that are relevant, that make sense in the context of a cloud or a kind of a DevOps technology, often don't work in this new surrounding. Let's dig into what I mean by that. So let's use a couple of examples. First, we'll talk about web app firewalls. So web application firewalls, they are basically this, you know, app level firewall. So it looks at HTTP and similar traffic, and it tries to identify SQL injection attacks and various others, and try to block them, not let them run. It's traditionally been an appliance. It was a box. You know, this is a diagram from Imperva. It's one of the leading players in the space that has, you know, a box, and you know, you put that in front of your web server, and that prevents attacks to the best it can from reaching your server. That is, you know, that's the way things worked when this firewall came out. That was the way you wanted to provision it in your sort of data center, right, and in front of your machines. But today, in this world of DevOps, you talk about cloud, you talk about auto-scaling environments. So how do you adapt? How do you block these web attacks when you no longer are running a data center and when your servers behind the scenes auto-scale? So you suddenly have a burst of activity. So it's simple, right? All you do is you take that web app firewall and you make it auto-scale. You know, simple diagram over here. This is straight out of the Imperva documentation. It's kind of easy to poke fun at it. You know, in reality, there's a lot of moving parts over here, but it is indeed, you know, while you might get entertained by the diagram, it is fundamentally a solution. So you need to adapt your web app firewall to be able to run itself as a VM and auto-scale launch more of these instances, in this case in AWS. So simple kind of mechanical adaptation that runs into it. This is maybe the most immediate, the most direct solution to this problem. But the other thing you can do is you can rethink a little bit about how do you offer that web app firewall, and you introduce these things like web app firewall as a service. So in the very same company here in Perva, I'm going to mention a lot of players during this talk. They are all examples. They're not, specifically different, maybe in many ways. And what they've done is they've taken their encapsula network and they've made that be more of a cloud itself. So instead of even provisioning boxes as a whole, can you just route your traffic through this third-party network, and that network would manage scaling up and scaling down as necessary. So it's a different methodology. So again, starting from simple, we're going to go to complex. It's just an adaptation for it. The other thing that these types of new approaches then in turn lead, if you talk about 1 to 3 steps here, is that they introduce an opportunity for new players. So players that were not previously proficient at doing web app firewalls, but they were proficient at being a proxy to your site. Notably, in the case of WAFs, are the CDNs. So you have Cloudflare, Fastly, Akamai, all coming in with web app firewall capabilities, web app firewall solutions, and offering them on top of a proxy they already knew how to do. And today they are amidst the leading players in the web app firewall space. So first example, again, quite simple about this evolution of adapting web app firewall capabilities from box to auto scaling to service. Another troublemaker, which will make a lot of appearances here in this talk because containers are firmly in this twilight zone between infrastructure and app, are containers. So once again, containers have some security needs that are shared with VMs. For instance, endpoint protection. So endpoint protection is this umbrella term for anti-malware and all sorts of other kind of bad things that might happen to your server around getting compromised or leaking information out. And they're relevant to containers just as much as they are to VMs. A container can get a virus on it, and you kind of want to know when it happened. There's nothing that automatically protects it. So how do you do that? How do you identify that your container has a virus on it, has been compromised, is doing something that it should not? Well, fundamentally, these machines or these solutions, the endpoint security solutions, they've been designed to run very close to bare metal, so they can really circumvent or sort of be able to detect all sorts of actions that happen on the machine. So it's hard for them you can't just run them inside a container when the container is not a true VM, right? Part of the advantage, part of the reason that containers are so lightweight is because they're not fully isolated from one another. And so solutions adapt. They adapt technically. For instance, Symantec, again, choosing the same solution here, has launched an endpoint protection system. I think they called it cloud workload protection, and that runs on your host. It runs on the VM still, but it protects the containers that run on it. And even that approach is not good enough for a system like AWS Fargate, for instance, which runs containers where you don't have access to the host. But still, it is an adaptation, a change that allows you to run endpoint protection on your containers. Sort of one third problem, last problem in the context of just this adaptation is this notion of patching your servers. I mentioned it a little bit at the beginning. Patching your servers is this very important thing. It means, you have your servers, they have a lot of these open source components on them, and over time, those components grow stale and they grow vulnerable. Vulnerabilities are found in these very popular components, from OpenSSL, which had Heartbleed, to Bash that had Shellshock. There's a lot of examples. Statistics show that unpatched servers are really the vast, by a huge margin, the primary reason for exploits that succeed. It's a lot of these vulnerabilities that have basically been on your system despite being known to the industry for a year or more. So you need to patch your servers. That's pretty known in the world of security. But how do you do that when your container is this disposable ad hoc thing? So, in the context of even a cloud machine, you can patch the machine, restart or patch the image, restart the server, and a new image will come up. In the context of containers, all of these dependencies, all of these installations happen at build time. So how do you, and you're going to take this machine that has a vulnerable component on it, you can restart it to your heart's content, and it would still have those vulnerable components. There is no refresh of the image. That's a part of the deterministic behavior of containers. So you need to adapt those solutions. And you see solutions, I give an example of Snyk here. There's like Claire, there's a bunch of commercial solutions out here that would introduce the very same notion of scanning, of finding vulnerable components, but adapt it to this context of a build system generated machine, in this case, containers. So this is sort of a family of challenges. It's the first type of problem that you come across when you want to apply security to DevOps technologies. Those solutions that are logically valuable but need to technically adapt. It's also probably the area where the industry is most mature because it's the first thing that security players had to do. The second class of problem that happens with DevOps technologies is new security risks. So once again, each one of these technologies introduces some new approach, some new way for an attacker or an evil player to might sort of step into your application. Let's again see a couple of examples here. The first example, maybe the one that hits the headlines the most, is unsecured buckets. These are all these S3 buckets and the likes that just have massively sensitive information and just were left there for the world to crawl and find out. There are many examples of those. I'm going to use an example of Uber. Uber, fortunately or unfortunately, gives us a decent amount of work, of material to work with in the world of security. Specifically in 2016, for instance, they had attackers access a lot of sensitive details, 600,000 drivers and 57 million users, which is pretty much everybody in the US, because those were secured on this type of insecure bucket. More specifically, what happened there was that you had a developer push S3 tokens to a private github.com repository, so still within the network, but that github.com repository was I guess wasn't sufficiently secure because attackers did manage to gain access to that repository. We later found out that they weren't using two-factor authentication. They used that token and they stole the information from S3. So this is an attack, still a little bit more sophisticated. In 2014, Uber had a similar hack. A developer, hopefully a different developer, stored sensitive URL in a public gist. So once again, there was a token, but that token at this point, you didn't have to compromise any credentials. You just have to find that public gist, and then you had that URL, and they accessed what at the time was very significant amount of data. Today, a smaller portion of Uber's overall data. And even that, you think you had an access key, but you find that you were lucky. For those who get the Monty Python reference here, those are still secured, and just the access key was mishandled. And the reality is that cloud buckets are very often entirely unprotected. And there's a myriad of examples here. I just picked 3. This is very much like shooting fish in a barrel in terms of finding examples of unsecured buckets. So this is very much an area where you could have had insecure buckets before. You could have had storage on the web that was unprotected before DevOps, but you didn't, because you didn't have as much of that sort of default, easy, cloud accessible storage. And now you do, you have to address the security risk. Just to note that this security risk is about unsecured buckets, but really a very close cousin is this notion of insecure configuration risks. And mostly we see this, if I just sort of move these forward, mostly you see this in the context of databases. So you see Mongo and you see Elastic, and really you see a lot of the others have default very open credentials, and then people incorrectly or insecurely deploy them on publicly accessible instances, and they just get compromised, super easily by attackers getting a lot of sensitive data about it. So this is an example of a security risk that gets created or just dramatically emphasized by these cloud technologies. And there you start seeing solutions that come up. Now, because these are new security risks, typically it's a little bit more the domain of startups to introduce new security solutions for it. So you see solutions like Cloud Checker that do these cloud security configuration assessments. They would scan and they would find all these open ports or insecure defaults over there. And then you also have some adaptation of existing solutions like Tenable, which has the famous Nessus tool, and then of course there are sort of commercial offerings on top of it, and they've adapted to be able to scan your cloud infrastructure. So they already knew to scan your data center. Now they can scan your cloud infrastructure and pull it and sort of ping for these types of insecure setups. So all of those are examples of solutions that adapt this new security risk. I can't really talk about any of these without talking about containers. They just show up in every section. Containers also introduce new security risks. As I mentioned, they're not fully isolated, right? You have these different pseudo VMs, but not fully VMs running on a single machine. So they create this risk of sandbox escaping, or escaping from the container, from one container to affect the host and therefore affect other containers, or even just affect the host, changing networking, leaking information, right? And this is not so funny when you think about this happening, in your cloud environment, right? Your cloud neighbor potentially reaching into your container. So once again, you have solutions that adapt adapt those environments. You have solutions like Aqua and Twistlock and other sort of runtime security solutions that introduce some protection, for this type of sandbox escaping. So all of these are examples of security for DevOps technologies and the challenges involved in those. Before I move forward, let's do a little bit of a survey and say, who kind of in the audience here is handling security for DevOps technologies, doing DevSecOps for technologies well. So Simon, can you run that poll?
So run that poll now, so you should be able to see that poll and run that. And just to summarize, while people are filling in this poll, then it sounds like there are two major pieces. Obviously, the technology has changed, and as a result, solutions have to adapt. So existing solutions can adapt, and they can still be very, very useful, so long as they just change slightly to be applicable for the new technology. And then also that technology changed has introduced new risks that are very specific to that new technology, such as configuration audits and things like that.
Yeah, precisely. And what you oftentimes see as well is that you see some of the same players, some of the same sort of solutions introduce a security product maybe that talks about, say, container security, and bundle in both the adaptation as well as some of these new threats.
Awesome. So pretty much everyone has voted now. So I'll close that poll and then share the results. So we can see the majority actually do not apply DevSecOps technologies in these critical applications. Does that surprise you somewhat?
Well, no, not so much, because I think this is still the evolution, and I think what happens is DevOps has been very compelling for the app side, for the business side of the fence. And people jumped in and they adopted things, oftentimes without necessarily looping security in. You can put some of the blame a little bit on the security side, which is security people to an extent. If you're one perspective on security is to think that you're safest if nothing changes, right? If nothing changes, then you don't really get an opportunity to cause a problem. And so for sometimes some security bodies are resistant to change for obvious reasons. They're kind of doing the risk management involved. So I think what happens is that the tech part, so the development, the application side of the fence, have oftentimes surpassed, they moved faster than security. And security today, I think this is also probably true for all of you joining in, it basically needs to make sure now that we have a good handle on handling this as we move forward. So yeah, so we have about less than 50% handling low, only about a third at moderate, and only a fifth of the people here saying they have a high level of control for these DevOps technologies, for securing these DevOps technologies. Cool, so let's go on. This is, we're at step 1 of 3. Let's go on to the next one. So the next step that we have, the next evolution, is the security of DevOps methodologies. So DevOps didn't just change the technology themselves, they changed indeed the methodologies. We're going to talk about 2 of them, CI/CD and microservices. CI/CD is maybe the anchor tenant of this whole DevOps revolution. It's this notion of continuous deployment, continuous building. You write software and you try to get it to production as quickly as possible, and you allow yourself some risk in the process. You accept that you would be shipping bugs, and you're comfortable with that because you might find those bugs in production, and you'd be able to quickly roll back or quickly roll out a fix. But that causes some challenges for security. So the typical security approach when you think about security anywhere in the process is to stop here and I will audit. Even if you're sort of forward thinking and you're doing this early in the process, you're stopping at the design phase, you're stopping early on, you're still stopping and you're doing an audit. And when you're talking about continuous deployment, there is no stopping, it's continuous. It always goes on. The teams are empowered, they run, we stop for nobody. So with that, stopping is not an option, and security solutions have to adapt. How do we adapt? First and foremost, automation. Now, fundamentally, this is an area where you'd say security and AppSec was actually ahead, was actually very, very advanced. We have SAST and DAST and IAST, also like static and dynamic application security testing. Hey, I was building those in the early 2000s. So in a way, the industry has been ready for it, kinda, not fully. So let's dig into the primary testing technologies and talk about the challenges they face. First one we'll talk about is SAST, Static Application Security Testing, or white box scanning, sometimes called. So the notion of SAST is fairly straightforward. It scans your code and tries to find vulnerable code paths. So it scans from sensitive sources, say a form field or the likes, where a malicious input might come in, all the way tracking data flows, all the way to a security sensitive sink, let's say a database write. And it tries to see if there is a sanitization or some sort of cleanup that happens in the process. And if there isn't, it would report that as a vulnerability. So fundamentally, SAST is a very straightforward thing to put into your build process. You find a vulnerability, you break the build, except it doesn't quite work that way. One of the reasons for that, or maybe technically the driving reasons for that, is just sheer time. So scans take hours, if not days, to run on, depending on the size of your sort of code base. And builds can't afford that amount of time. Builds are continuous. They take minutes to run. If you add hours to a build, you're going to be out of that build pretty quickly, no matter what your sway is in the security space. So the security world has adapted. And the primary adaptation we've seen in the world of SAST is that you run these long scans, is this notion of incremental scans, which is you run these long scans on a weekly cadence, or monthly or others, and then you run these incremental scans, these delta scans in the build that only test the delta, the difference between that weekly scan and your current build. And those scans presumably will take a shorter amount of time. So that's an interesting adaptation, and it is indeed used in a decent amount of build and CI/CD environments. They're still oftentimes not used to break the build, and that is a different problem. It's because these SaaS solutions tend to, on average, just not be sufficiently accurate to break the build automatically. So what you see much more often is that the results, they still run in the build, but they log issues, or they would funnel those results into some portal where some human still needs to review them. So not quite there, but getting there. So this is SAST. I see it somewhat in build systems, rarely to break the build, but still, it has a decent presence in build systems to at least run. The second class you see is DAST, or Dynamic Application Security Testing. So this is the black box testing. It basically takes a deployed instance of your app and it tries to hack into it by putting all sorts of funky values into the fields and seeing what happens. This is, once again, a very automated type of scan. It's an automated attacker. However, it has some challenges to run it in the build. One, scans require a dedicated environment, and oftentimes you don't have one. Ideally, you have one for end-to-end tests as well, but oftentimes you don't. And the second is, once again, these scans take a very long time to complete. In fact, in modern applications, this is a problem even when you run them manually. So how did the industry adapt? Well, to an extent, they have adapted, or like the industry has adapted, with this notion of IST, of interactive application security testing. IST has a bunch of different meanings, but in this context, I would refer to the fact that you instrument the application, so you include some library that adds kind of like a New Relic style hooks into your code that inform some central portal about what happens inside the system. And then you run your regular unit tests. So you run the unit tests that you would do anyway, the things that invoke your systems, that test functionality. And the IST solution would try to explore the information or sort of understand the system through the flows that just got exercised and deduce security issues. By definition, if you've run only a subset of these tests, it's only a subset of those paths that would get used. So it's less comprehensive, but it works with less overhead. It's faster. It doesn't scan the entire application, and it is very imperfect because it still misses a lot of issues, but it does still sometimes work. There are a bunch of IS solutions in the world right now. There's also the same approach, I guess, without necessarily IS, is being used by OWASP Zap, by the open source Zap solution, which once again kind of hooks into the unit tests and run as part of those unit tests. So it's an interesting approach. I would say still the primary adaptation that has happened for DAST in the world of CI/CD is not to use DAST in the build, to still run DAST off to the side. IST is an evolution a little bit in the space. Just a quick shout out to an interesting approach that I'm still a little bit half-minded about, which is you can invoke scans as part of the build and then test them asynchronously. So you see this happening specifically. I've seen Detectify, which is a slightly newer player into the space do this, which I like their notion. You scan maybe your staging or your test environment out of band, but you invoke that scan in the build. And I guess it depends a little bit on timelines of completion to see if that works or not. So 2 out of 3 solutions, I guess, that we talk about. The third, and maybe one that is most used in the CI/CD environment, is this notion of software composition analysis, or SCA. This is the idea of indeed flagging vulnerable libraries. And this one is much more, it's a newer concept. It deals with open source libraries, which arguably are on their own right, cloud sort of DevOps technologies. And it tries to find which components you're using and then break the build if one of them is vulnerable or has a license flag or something like that. And it is naturally CI/CD friendly. So you see a lot of that adoption. SCA is used predominantly, maybe even in these CI/CD environments to break the build if you've added a vulnerability. It's very fast, it's very accurate, very easy to merge in. But even in this world, there's evolutions on here. I'll show a couple of examples using Sneak, kind of our own solution for this, to talk about how can you still evolve. There's still an element of how do you level up the way in which you engage developers with this. One is separating new vulnerabilities that were introduced due to developer action. So a developer has just added a library, and that library is vulnerable, and therefore you want to fail this PR, you want to break the build, from the ones that are notifications. When you have a notification of you were using a library, that library was totally kosher yesterday, but then today a new vulnerability was discovered on it, and you want to alert a developer about it. In that second case, you don't want to break the build, right? If you break the build, you're just disrupting everything. You've not made your system any more secure. You're already using the library, a new vulnerability has come along. You're not adding any security, but maybe even more so when you talk about a continuous process, you've stopped the process and the developer has never really done this, right? As a developer, I've made a totally unrelated set of code changes. I run the build and suddenly the build breaks. That's flakiness. That's something I don't like in my build, and I will take you out. So this idea of separating, putting, for instance, what we've evolved here is that we will fail newly added vulnerabilities. We will fail those as part of the Git surroundings. And when a new vulnerability is disclosed, we will alert you out of band and we'll open a fix pull request, another sort of mode of engagement with you. So that's CI/CD and some evolution about security for CI/CD and how do you adapt it. The second example I want to talk about a little bit more briefly is microservices. So microservices is really challenging, shall we say, for security. When you think about this monolith to microservices, this idea of taking this big box and splitting it into a lot of, maybe containers, maybe others, think about that monolith. From a security perspective, it is very convenient. You have this big box, that box has a bunch of these inputs, has a bunch of these outputs, and you just monitor the inputs, you monitor to see that nothing wrong got leaked out on the other side. And that's not easy either, but it's much easier than thinking about microservices. Microservices are a mess. There's a lot of different components. They keep shifting around. You can secure each one of them and still have a bad, problematic flow of data between them. Things change all the time, both the individual components and how they are interconnected, and they all get constantly deployed. So it's a mess, and it's really hard to think when you talk about security monitoring in this environment. How do you even understand what is the whole? What is it that you need to monitor? So once again, because this is a new type of security risk, you have, because it's microservices and it's newer than CI/CD, you have newer startups coming along and offering solutions for it. I'll give a couple of examples. One is, or three actually. One is this view from Appareto. What they try to do is more visualize the data flow across the different apps. So try to indeed understand what is the whole with these circles and what are the parts, and understand how data flows and whether that is legitimate or not legitimate based on your network. So that's an example of monitoring the different microservices. Another example of an evolution is around installation. So when you have that big monolith and that big VM, not to say bare metal, then you can SSH into it, you can connect into it, you can install an agent. In the world of containerized components, you deploy a lot of those components. The build happens, the container, the image gets constructed at the build. So you need to install your agent, if you will, as part of your Docker file. And you can see that installation in Signal Sciences. A bunch of other players here work as what they call a sidecar. So you run a container within the cluster and it engages with your system. But you have to rethink how do you do installation. And then a third example kind of evolution in the space is Small Step. And what they do is more about identity. So you now have a bunch of these microservices. How does one microservice know that it's talking to the right other microservices? And so this is a newer solution that tries to be, if you're familiar with it, kind of like Let's Encrypt for internal identities. This idea of giving a very high scale, high efficiency, fast issuance of a certificate ID to each one of the different microservices that are in your environment. So to kind of summarize a little bit, we talked about technologies, we're talking now about methodologies. You have to make sure that when you adapt or when you adopt these new DevOps methodologies, you also have to adapt your security practices to it to stay relevant, to be able to apply them. You can't just stop scanning, stop finding these vulnerabilities. You have to find the right way to do it in a way that doesn't stop for an audit and that scales into these different microservices. The second thing I have to say about DevOps methodologies and security for DevOps methodology is that they're not just bad, they're also good. This is maybe one of the big conversations that's happening. Is DevOps good for security? Is it bad for security? Well, it depends, or it's both. Fundamentally, there's a whole set of opportunities. There's a set of these challenges, as I've sort of spoken to up until now, is a little bit doom and gloom, right? A little bit the challenges you have to deal with because developers have switched and adopted DevOps. But there's also a set of these opportunities, these advantages that these methodologies give us. And if you want to really, get better, or if you want to come out the other side stronger, then you need to think about how do you tap into those opportunities to improve your security posture in things you couldn't do before. And I'll give a couple of examples. Maybe my favorite example is, what do you do when you find an intrusion? So, when a VM misbehaves, and you see some problem binary, it's a little challenging to figure out what you will do now. So you have a running process, it's behaving suspiciously. You need to start quarantining it. When do you not do that? How do you notify? When a container misbehaves, you just kill it. You just shut down the container, and whatever bad thing has happened to it is gone away, unless your actual image is malicious, which is a bigger problem. You would just spin up a new one, and you'll be fine. You still want to know, you still want to find out how you got compromised, but you've resolved the situation in a much cleaner fashion. So I really like that approach. Another example is, indeed, we talked about CI/CD challenges, but fundamentally CI/CD gives you an opportunity to do two things. One is it gives you a paved path to apply a security patch. It means there's a fast and easy way, once you have fixed the problem, to get that into production. And two, this is more the CI side, is that allows you an automated security gate. It gives you a natural place to put your gating functionality, to put your policy enforcement all the way to production early in the process. So it's a very, very powerful opportunity for you to sort of partner, a place for you to partner with. And this is a little bit more forward-looking, is I think up until now, this notion of integrating into CI/CD and all that, they're becoming, like, again, not everybody is in that place, but they're becoming a little bit more well-known. I see maybe as a next step of evolution is this notion of GitOps. So GitOps is integrating with these GitHub flows and the likes. And what they offer, as opposed to a build, is they offer a much more interactive environment with the developers. So you can do a security code review that just gives information into a pull request and therefore informs you about a potential security problem. You can fail only on a specific delta, like I've shown before with the vulnerability. You can fail the build if there is a vulnerability here. You can fail a pull request if this specific, like in a much more granular fashion, if this specific set of code changes has introduced a new problem. So you can get more granular, you can get more interactive, versus the sort of sledgehammer, break the build, don't break the build approach that CI/CD gives you. So I think this is a world of opportunity for us. So that was sort of 2 of 3, talked about security for DevOps technologies and now methodologies. We're going to take another pause here to say, if you're listening here, how much would you say, or how deeply would you say you apply security for DevOps methodologies? You're sort of building in those practices I have just mentioned.
That's
so
awesome.
I think
Thank
Simon's
you.
kicked off. Yeah.
Yes, I've just kicked off that poll, and again you have low, moderate, or high. Very interesting to obviously see the evolution of security tools as we go from that traditional space where we traditionally had to stop for an audit every 6 months, a year, or however long it took, whereas now we're trying to push a lot of that great testing back into that CI/CD pipeline, which takes minutes and hours rather than the days or it used to. So yeah, as Guy mentioned, SAST, DAST, IAST, SCA, these kind of tools, and obviously the new security tools, which also Guy mentioned, that are being pushed into microservice technologies or GitOps flows. Which of those are you using now? Looks like everyone's just about finished voting, so I'm going to share those results with you as well. And your impressions on that, guys, similar to the previous poll?
Yeah, indeed. So again, not terribly surprising, because we're still learning, we're still evolving as an industry. Actually, numbers are a little bit better even than I expected. We see about 50% at low, a little bit worse, I think, if I remember correctly, than the previous numbers. Then about 32% is moderate and 19% is high. I would suspect a lot of the ones that have marked it as medium or high are oriented more at that CI/CD, I would say, of all the practices that I talked about right now. Putting some form of security testing into your build system is just so compelling that I've seen that to be adopted quite a lot. What I haven't seen happen too much is people actually breaking the build, so actually putting that type of enforcement into hard action. But it's actually good. It's encouraging to see numbers a little bit higher than I expected on the moderate and high that combine to about half the audience.
Well, why do you think that is, Guy? Because I mean, is a security issue not as important, if not more important, than say a unit test issue or just a regular test issue?
So I think a lot of it comes down to ownership, or what do security teams feel they're allowed to do, or maybe what the dev teams feel their security team is allowed to do. So they might not feel they have the mandate. It's not necessarily their turf. So that's one holdback that I see a lot. They're not allowed to break the build. And that's more of a relationship. We're going to talk about that in a sec. And then the second bit is more about accuracy and practicality. So it's those very challenges we spoke about just now, which is if the build takes too long or if the results are not accurate enough, you just don't break the build. And so you find yourself really reverting to only breaking the build in the very small subset of cases where it's very clear cut. And hopefully in the world of SCA, it's a little bit more concrete, but even there, oftentimes you would only break the build on these critical vulnerabilities. And we're hoping this Git integration that's more elegant, more refined, helps inform developers, and then they choose the right solution versus, again, just pull the cord and stop everything. Cool. Let's continue on. So fundamentally, we talked about a lot of things, but we've seen a lot of, like, if you sort of take those two first sections we talked about, a lot of them also apply to past technology revolutions that we've had, notably virtualization and mobile, where they also introduced they rocked the boat around how we do things, and they had to adapt. I think maybe one thing that is a little bit more specific to DevOps is the dramatic changes done around people and around ownership. So let's talk about that. Let's talk about including security in the DevOps shared ownership mindset. And this one's a little bit more meta, a little bit more high level. So stop to think about a little bit about how do we live, how do we work in this DevOps world? So DevOps means that developers are more powerful than ever, right? DevOps is all about this continuous element and around getting developers to own more, to have more responsibility, but to own more. One aspect of why we do this is to allow them to ship code faster, and that is happening. I remember I was a programming committee member for Philosophy for many years, and when John Allspaw came up and talked about, I forget, like in Flickr, they were deploying 40 times per day, and people were like, oh, that's irresponsible, that's a disaster, it's never going to happen. And today, that is common practice. That's kind of slow. You probably ship more times than that per day if you've embraced DevOps. So the pace is moving very, very fast. Developers have a lot of access. You access production systems daily and access user data daily, both of those under that mantle of being able to operate the software that you develop. And then you throw in the fact that a typical ratio, there's no exact math here, but typically when you talk to companies, this is about right, has a roughly 1 to 100 ratio between the number of developers and the number of product security, application security, or even security personnel as a whole. And you reach the maybe obvious conclusion, which is developers cannot outsource security because nothing else scales. Nobody else can keep up. And this is the fundamental need that we need to have. We need to figure out how do we bring security into the fold of DevOps, to be a part of this shared ownership. So the good news is that developers also think this needs to happen. We've done this survey, State of Open Source Security, and we included a few questions about security ownership. And both when we asked them in general, this is the 81%, and when we asked about container security responsibility, that's the 68%. Developers very much felt like they should own responsibility, and it's a good path for embracing this type of responsibility. But we have some challenges. The first challenge that we have is the tooling. So security tools fundamentally are designed for security professionals. And basically, if I look at my own history, I built a product a decade ago or so called the AppScan Developer Edition. It had developer in the name, but really it wasn't a developer tool. It was a static analysis tool, and it was built into Eclipse, and it dealt with source code, so we called it developer. But it wasn't. It was an auditor tool that was built into a developer environment. It didn't truly factor in the development developer needs, the use of the developer, what is important to the developer. So just building a Jenkins plugin or just shifting left in the notion of running your security tool earlier in the process doesn't make it a developer tool. What does make it a developer tool? What is a tool that developers would actually want to use? Well, there is no single silver bullet, but I'll give you a few examples of good properties of developer tools. One is good documentation. Developers like self-serve capabilities. They don't like talking to people. They like to be able to actually get their hands dirty. And security solutions or security-minded solutions like Auth0 that have really good self-serve documentation do well because developers value that. Stripe outside of security are actually very well known for how good their documentation is. Very related is the ability to try self-serve. Security solutions are too often sold top-down with these monster deals where you have to work so hard to just be able to get your hands on the software. That doesn't fly with developers. Developers need a very quick ability, kind of this ADHD. You've got 15 seconds to make an impression. And again, security solutions like HashiCorp Vault, which is a key management system, they do very well, clearly goes hand in hand with that documentation, and just letting you try and get going very, very quickly and without talking to anybody. Security solutions that get adopted by developers understand that those are developers and non-security experts. PagerDuty is a good example where they do this incident response training. PagerDuty is a more of a DevOps tool, if you will, but it is oftentimes used for security incidents as well. And they've open sourced their own incident response methodologies in language and terminology that is oriented at developers, at non-security experts. And then last but not least, it's about actionability. And it's fairly simple math. If all you do for me, a developer, is make work, if all you're doing is you're creating and adding things to my backlog, you're not going to be my favorite person. What I want you to do is I want you to help me fix these things. I want you to help me act on those components, on those alerts. So you have to make sure that these are actionable. In the case of Snyk, I've kind of mentioned this before, we open automated fix pull requests. Are they perfect? No. Are they helpful? Super. And people hit merge and they're just off to the races. And though that's a property that people really, really like around help them make the problem go away. So you want to find or build, if you're doing this internally, the security tools that your developers will actually embrace. The second challenge we have is really maybe the most amorphic one, which is people. So how do you get the dev teams to embrace security, and how do you get the security teams to embrace development? Because I do think that we have challenges on both sides. So this is very much a no silver bullet solution, but we do have advice for some smart people around it. So I have the pleasure of running the Secure Developer podcast, and I've had some really smart people on it, CISOs of a variety of companies and security teams from a variety of companies that are doing this well, right? That are sort of embracing getting their development teams and their security teams to work well together. So let me share some highlights of those, and you're welcome to listen to the podcast to sort of hear some more. So one example is from PagerDuty. So the PagerDuty security team came on board, and they talked about how their job is to make it easy to do the right thing. There's how much you care about security, and there's how hard it is, and you need to care more than it is hard. That's really all you need. Now you're going to inch up how much you care, but you can really drop to the floor how hard it is to do something, and humans will respond. The second thing they talked about is around tooling, to say they treat security problems as operational problems, and they use tools that are ops problems as security solutions, PagerDuty itself being one of those, and that again kind of helps make it easy because developers don't need to learn a new tool. So that's one example. The second example comes from Optimizely. So Optimizely, what they try to do is they try to celebrate success. So security is this world of shaming. Oftentimes you just point fingers when somebody's done something wrong. What you want to do is you want to also celebrate. You want to be builders, not just breakers. In the case of Optimizely, they do these t-shirts that say security hero. They're kind of exclusive. People walk around, they show it, and they also, it makes people want to get those shirts. Zach Powers at One Medical talked about it. Hoodie-driven security, talked about giving out hoodies, to a similar effect. So, very, very useful. And then once again, they use Spinnaker and they use kind of ops tools, not just dedicated security tools, as part of their security stack. New Relic CISO talked a little bit more about the opposite, about what you should not do. And Sean said that the best way to turn a developer off is to give them unactionable information. Kind of goes back to my point from before, giving them something they don't understand or they don't know how to fix it. So you're making work for them and you're just making it muddy and you're just going to point fingers at them after. They're not going to like you. You want to give them things that are useful, that are actionable, that's very clear what to do next. The second thing he pointed out was more about org structure and how they changed the way they do security to fit the world of developers, sort of, to sit with developers. So he actually he didn't reorg when he was hiring people, unlike what he originally planned. He actually set them down with developers, kind of with the dev teams. He makes sure that he has coding skills built into those teams. That was actually very much a repeat theme in future conversations. So try to make sure that security adapts to dev and not just always expect dev to adapt to them. And then last example is from the Slack CISO, Jeff, and he talked more about even meta org structure. He talked about how security moved in the company from being sort of more in the sort of IT and kind of cost center to being more of a first-class citizen in engineering. And Slack has been doing a great job recently talking about signatures, talking about protecting your data, making security be a business advantage, and talk about how we all rise and fall together, right? The other thing they do really, really well in the sort of we all rise and fall together, which is a great community element of it that you don't see as much in security, is when they've seen teams in other companies, even competing companies, running through a security incident, they send them cake or pizza and sort of some friendly Twitters to help them get through the day. And you see that more now between these modern security teams, which I love. So you want to look for ways to engage developers in security and really, really double down on those. So that's it for the third section. I'm going to summarize in a sec, but before that, we're going to run one more poll with sort of that same question about, do you include security in DevOps shared ownership, right? Do you feel like you have that in your organization? Simon, can we run the poll?
There we go, running that poll now. Similar answers, low, moderate, or high as to what you do in your organization. Really interesting subtlety in what you're talking about here, Guy. Do you feel like it's harder to change the mindset of individuals rather than changing tool sets or technologies?
Absolutely. People are the hardest thing to morph. They're also the most powerful one. At the end of the day, they are the ones that do everything, right? We are all people, and doing the right, kind of having the right shared mentality, being one team working together, delivers good things. But changing habits is also hard, and you have some people also sort of afraid of the change. They're not sure they will do as well in that new surrounding. Or sometimes even fear for their job. Hey, if I automate so much of the security, if developers take ownership of security, what do I do? And you have to remember that, take a look at what happened in DevOps. In the world of DevOps, these what used to be sysadmins and IT people became these system reliability engineers and DevOps engineers. Their salary doubled, and they're much more sought after. And what happens is that they use their expertise to automate, to build scalable solutions to guide others versus doing a lot of the daily operations. And that's what we aspire to in security.
Mm-hmm. And let me share the results of that poll now. And the highest high we've had so far at 27%.
Yeah, that is actually surprising and really encouraging. It means people are embracing. So 27% high, still, unfortunately, only about a quarter of the audience are applying this. But I love the fact that, I think maybe it's a symptom of the fact that the people that have tuned into this webcast, right, to this webinar, you want to hear about this. You want to think about how do you apply DevSecOps, which kind of almost in its nature talks about the shared ownership. So that's really great. let me summarize and we'll open it up a little bit for questions.
Yeah, and I'll just
So,
say, just before you summarize, Guy, we have some great questions in already on the GoToWebinar control panel. For those of you who haven't asked a question yet but do want to, please go to the questions tab, type in your question there, and I'll ask them straight to Guy straight after this summary. Thank you.
Perfect. So let me just quickly summarize. So DevOps helps you deliver value faster and adapt to market needs faster, and do all of those at scale. We talked about splitting DevSecOps into securing DevOps technologies, methodologies, and embedding security into shared ownership. And I guess I'm not going to run through these too much because we talked about them too much, but in each of those areas, you have a couple of levels of adaptation. So before I close off, I'd say one last point, which is all of this evolution really has it backwards. This is the evolution because it's about how the industry has changed, the easiest things to move. But fundamentally, DevOps is first and foremost about people. If you embrace the DevOps shared ownership of security, if you get people to think about, if you get developers to think about security as an aspect of their responsibility, if you get security people to not see developers as this threat, but rather as a partner for the journey, and you get those minds working together effectively, all the rest will follow. The methodologies will come, the technologies will evolve, and you will be successful. So with that, thanks a lot for those tuning in, and let's take some questions. What do we got, Simon?
Awesome, thank you very much. So yeah, you can ask questions as we go, and please remember we do have a draw for the 3 $50 Amazon vouchers at the end as well. So straight in, we have a question from Jamie asking, how do you convince an organization that DevSecOps requires a different mindset on security? So where a traditional security consultant on a project is no longer sufficient to secure the code base, the container images, and so on.
Yeah, I think so. Hopefully, this gives you a little bit of ammo here with this flow, so you can split up a little bit and maybe understand what scares you the most. Is it around, one aspect is the understanding that you're introducing new technologies and they have new security risks, so you have to invest in ensuring the same questions. That, hey, you justified, or before you thought it was right to have malware detection on our VMs. Don't you think it's also necessary on our containers, and do something about that? The second, and maybe most powerful, is to talk about not negating the value of DevOps. So, you ask, okay, why are you doing DevOps? What's the bottom line reason that we're doing this digital transformation, that we're embracing DevOps? Inevitably, the answer would be speed, because we want to adapt, we want to move faster. It says, well, if I introduce security gates, I will, one of two things will happen. Either people will circumvent the gates, which we don't want, so we'll deploy things that are insecure, or if security has enough power, we will stop. And you'll basically be losing a lot of that value, a lot of that speed, a lot of that acceleration that you would have gotten from the DevOps journey. So you can talk about how you have to adapt your solutions to be able to accommodate the business returns, the results that you're going to get at the end of that. And then the third thing about the people, I find the most effective one is to talk about talent, is to say, hey, if you talk about hiring the right security people, if you talk about hiring forward-thinking developers, then those people would want to be at the sort of modern software development practices, and the best people will be looking to join an organization that works effectively this way. The other aspect is just about implementation, right? So if you hire the wrong people, or if you're not striving for this type of shared ownership, you're just never going to be truly successful in the first or second bucket.
Awesome. Great question here from Magno, asking if you had to choose one of the tools or processes to start applying DevSecOps on a DevOps company, which would you recommend? You mentioned SAST, you mentioned DAST, IAST, SCA.
Yeah, so I think I do think SCA is the easiest way to start because of the reasons I mentioned, which is just the accuracy and the speed of them are straight up. I think SCA solutions have evolved to be most dev engaging. I'd very much encourage you to try Snyk and sort of see if we deliver over there. But just fundamentally, what you get from SCA, from implementing SCA first is a few things. One is you're tackling a very big problem right away because you're tackling this notion of vulnerable open source library, which, by the way, by doing DevOps, you're probably using more of. So you're sort of tackling a growing problem. The second thing you're doing is you are demonstrating to developers that there is such a thing as a developer-friendly security solution. So you have to choose your sort of SCA solution carefully, but because they are more naturally inclined, because this category is more naturally inclined to DevOps, then you can start with a success. You can start with something that shows that it works, and you have something to aspire to when you introduce the more complex tools. And then the last bit, so specifically for Snyk, you might find others. What we do is we do a lot of these automated fixed pull requests and the pull request integration that likes. And what that does is it raises visibility. One of the challenges with security is that it doesn't have a natural feedback loop, right? There's nothing that naturally tells you that you're doing something wrong. And by opening, a fixed pull request beyond the usefulness of merging that pull request, everybody watching that repository, the team working on it, will get an alert, would get a message, and that would remind them, even if you didn't do anything about it, that would remind them about security risks, about security problems, and once again about the usefulness that a security tool can offer. So I'd very much start with SCA and work your way down.
Okay, awesome. We have time just for one small question left, and then we'll wrap up. There are a number of questions, but we'll make sure that that Guy sits down and answers all the questions before he's allowed to leave his office tonight. So the final question: do you have a recommended reading or training for DevSecOps or building collaborations? Question from David.
So I'd recommend the security developer community that has a lot of great content about security and developers. There's the podcast that I mentioned, but there's also a whole community and a series of tech talks. I very much like DevSecCon, which is a conference that runs a few times a year across the globe and has great content on this material. If you're looking for more of a business driver and an understanding of how to sort of convince your business, indeed, per the first question, Nicole Forsgren's and Dora's book, Accelerate, summarizes a lot of information. It has chapter 6 there that's all about security, and it has a lot of reasons about why you should embrace DevOps as a whole from a business perspective, and specifically about adapting security practices. So I recommend that book as well. And yeah, we're evolving as an industry. Check out on the Snyk blog itself. We try to post useful cheat sheets and other more concrete advice.
Excellent. Thank you very much, Guy. And thank you for everyone who has asked questions. And as I mentioned, Guy will get to those questions and we'll send you those answers directly. A couple of things before we finish up. The event is recorded and we will send you the link in your email with the recording. So don't worry if you joined halfway through or you want to watch it again. You'll get the whole webinar again in a recorded replay. The draw for the three $50 Amazon gift cards has been made, and the winners are the three lucky winners are Carolyn O'Connell, James Andrews, and Quentin Gurney. And we will this is run by Media Ops, the company behind Security Boulevard, who will reach out to you after this webinar is complete. So last thing I'll say is a big thank you to Guy, and a big thank you to Snyk, and a big thank you to the Security Boulevard for running this webinar. Thank you very much, Guy.
Yeah, thanks for everybody tuning in, and to you, Simon.
Thank you.
Cheers.